Okay, we'll start now. Okay, so in this lesson, which is the last one of this chapter, we don't have any new rules. Instead, we're just going to use our rules to solve practical problems. So it's not like there's one way to do all of these. I think I'll just do a couple of them as examples and then let you try. So if you can look at page 44, please. Practical problems. Okay. I'll do a couple as an example. So we'll start off with an easy one and then we'll do a harder one. So the first one here is, what is the sum of the first 100 numbers? So we have 1 plus 2 plus 3, etc., etc., all the way up to 100. Well, what type of sequence is this? I mean AP or GP? Yeah. True, it's divergent. AP, A equals 1 and D equals 1 and N equals 100. So the answer will be N over 2A plus N minus 1 times D, which is 5050. So if you add the first 100 numbers together, your total will be 5050. What? Okay. Let's try another one now. But rather than just do these directly, I want you to try first to see if you can figure it out. So, can I scroll down? Yeah. So in number 6 now is another example. No, sorry, not number 6. No, yeah, number 6. I'll do number 6 and then I'll let you try another one. Number 6. A ball is dropped. During the first second of motion, it falls 5 meters. And then in the next second of motion, it falls 10 meters. And in the next second of motion, it falls 15 meters. If we could do that, yeah. How far has the ball travelled after 10 seconds? Yeah. 5 plus 10 plus 15. We know it's 10 seconds, so there's 10 of these. And we know the A is 5, and we know the D is 5 as well. So in total here we'll get N over 2A plus N minus 1 times D. So what's that? That's 4555 times 5, 275, isn't it? Yes, 275 is meters, is the answer then. Yeah? Thank you. Okay. Now let me give you one to try before I do it. So let's try. I'll give you an easy one to start with. We'll do 8, 9, 10 together.
8.
Yeah, but I just want you to try 8 first. Here you go. So I'll just give you a minute to try number 8. Got it done? Should be a pretty dang big number. What have you got? That would be key information. Maybe one of these dudes know.
Chinese.
How many in a Chinese one? I'm shocked. I thought this was general knowledge. 64. You were right the first time. 8-8. Yeah.
8.
No. 64. Okay, do you have this one finished? Sammy, Victoria, did you get this one? Not yet? In case you didn't know, it's 64 squares on a chessboard. Okay, I think that should be enough time. Jonathan and Clement, did you get an answer? Not yet? You got an answer? Okay, maybe I should do it now. So, what you have here is, you have a chessboard.
How many?
I told you. 8 by 8, yeah, so there's 64 squares. And I tell you, on the first square you place 1 grain. On the next square you place 2. On the next one you place 4. And on the next one you put 8. And you go all the way around to the end. How much do you have? So the answer is you want to calculate F64, which is 2 plus 4 plus 8 plus 16, etc. This is GP, with A equal to 2 and R equal to 2. So you have A 1 minus Rn over 1 minus R, which will be 2 power 63 minus 1. Huh? Oh, you start with 1. I'm sorry. Dun, dun, dun. 1 plus 2 plus 4 plus 8 plus 16. A is 1 and R is 2. So F64 is A 1 minus Rn over 1 minus R. That's minus 1, so that's 1 minus 2. Yeah, so this is 264 minus 1 then. Okay. Which is a pretty big number. 1.8. That's about 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I don't know what this is called. 1,000, million, billion, trillion. Hang on, I'm counting. Right. That's 1,000. Is it billion, trillion? We'll get there. Million, billion, trillion, thousand trillion, million trillion, 20 million trillion. Yeah. Big number, big number. This might be surprising because it doesn't seem like it should get so big, but the effect of multiplying by 2 will get really big. So even though these grains are really small, little grain of food, by the end of it you're looking at sort of the total amount of food in the world in grains. Yep. So it grows really quickly on the chessboard. Yes. Just balanced all there. Okay. What's the next? Is the next one about the ball? Yeah. Okay. So now try the next one, and I'll do it. So you try. What's that? Number 9, is it? Get an answer? How far are you in it? Good. Yes.
Can be 0.
Well, gets closer to 0.
Yeah, very close.
Exactly, can't really be 0. In real life, but in this simplified model, it just gets smaller and smaller. Any answers? It continues forever. So it's an infinite sum. I know, but the difference between that and this is actually too small to care. So we can model it as if it bounces forever. Answers? Will we look at it now? Yeah. So, you think, okay. Jerry's going to get it for us. Yeah, you're going to get the right answer, aren't you? And then you're going to show us. No? All right. Oh, you've given up?
I give up.
You give up? Okay. Will I do it now, this one? Yes, why not? Okay, so what height is the ball dropped from? 1 meter. Okay. And it bounces back up to a height of 0.8. And then 0.64. And so on. Now, I know it's not really moving to the right, it's just how I drew it. It's just moving up and down like this. Just straight up and down like that. Okay, so let's add up how far it has travelled. So it has travelled in total 1 plus 0.8 plus 0.8 plus 0.64 plus 0.64. What do you mean, why?
It goes up and then it goes down.
No, I never said it went up, did I? I said it was dropped from a height of 1 metre. Yeah. Gotcha. So, this was actually an exam question in the final exam a couple of years ago. And the person who put this question in it was being very mean, I thought. That was me, by the way. So, when I gave this question, only one student got it right. Yeah. The good news is I'm not writing your exam this year. Yeah, that's the good news. Huh? I don't remember his name because I will forget all of your names next year. But it was one person, that's all I remember. Yeah. So, I think most people probably wrote 1 twice. Or maybe even some people just wrote each number once. But this is the correct one. And now that I've done it, you can see it's correct. So let's add this up. I'm going to keep this 1 by itself. And because each of these happened twice, I'll multiply it by 2, but only add each one once. This here is GP infinite, with A equals 0.8 and OR equals 0.8. So this will be 1 plus 2 A over 1 minus OR. That's 0.2 goes 9 in total. Huh? I did add the 1. This plus this equals 9.
I think the question should be like the first number.
Should give me the what?
Like 0, 0.8 and 0.3 for another number. We can get it multiply with it.
Let's see what I said. No, I gave you 3, which was enough. I said 1 meter, 0.8 and 0.64.
Just 3 and 1 is not enough.
But when you look at the sequence here in the question, 1, 0.8 and 0.64. You can, okay, let me, if you prefer, you can write it like this. If you don't like that, you can write this. Minus 1 plus 1 plus 1 plus 0.8 plus 0.8 plus 0.64, 0.64. So that'd be minus 1 plus 2 times 1 plus 0.8 plus 0.64. If you prefer, you can include the 1. So this will be minus 1 plus 2 times A over 1 minus OR. So that would be minus 1 plus 10, which is also 9. So you can include it if you really, really wanted to. But I don't. So I'll do it like this. Yeah. Okay. That was hard. Now time for a harder one. Try the next one. What number is that now? 10? I'll just check the attendance while you're doing that. So is it Alvin still here?
Yeah.
Let's try that again. Alvin?
Yeah.
Amelia?
Yeah.
Tony?
Yeah.
Clement?
Yeah.
Jonathan? Dana? Dylan? Drew? Hanukkah? Yash? Eric?
Yeah.
Andy? Dennis? Sarah? Yep. And Fahad? Andrew?
Yes.
Bruce?
Yeah.
Monica? Chrissy? Jerry? KJ? Brian? Lee is still at GNIB? Yeah. Victoria? Yeah. Sean?
Yeah.
Sammy? Well, I still see people working on this, so that's a good sign. Okay, anybody get the answer? You think you got it, KJ?
I look like it.
Does that mean you got the answer? You got it? Okay, let's have a look at it now. Can I borrow the book there for a sec so I can get the info? Let's have a look. Okay, so we're told at the start of this year there were 143 billion barrels of oil. This year we will use 30.775. So this year, this is how much oil the planet will use. We'll use 30.775 billion barrels. Now if you look, oh, that's great, because we have 1,433 and we only used 30 this year, so how many years should it last? Well, what's 1433 divides 30.775? What's that number? 46. So you might, So you might think, well, that's great, so that will last 46 years or whatever. But then the problem is, we don't use 30.775 every year. What will probably happen next year? We'll use more, exactly. Yeah, so the question says next year we'll use 31.544375, and next year we'll use even more. What's happening is each year we're increasing by 2.5%. So is this arithmetic or geometric? Geometric. What we're doing each time to make the number 2.5% bigger is we're multiplying by 1.025. This makes the number 2.5% bigger each time. So this is a GP with A equal to 30.775 and R equal to 1.025. Yep. But what must the total equal? Yeah, this is what the total usage must be. So this means A 1 minus R power n over 1 minus R, that should equal 1433, which means 1 minus 1.025 power n should equal 1433 times 1 minus 1.025 all over 30.755. Is that right? Oh, 775? Thank you. So that means 1 minus 1433, 1 minus 1.025 over 30.775 equals 1.025 power n. Can someone hit that in? You have the left. What is it? 2.164 equals 1.025 power n. Yes, now, we haven't done logs yet to solve this. So the only way to solve it is by guessing. But it's not too bad, because we know what the biggest answer could be. 47, 46, yeah, that's the biggest answer. So it's probably not going to be close to that. It's probably going to be less than that. So I would try at 40 and see if we're too big or too small. So if I try 40, so that's too big, is it? Okay, try 38. You're saving me the trouble. Is 31 for sure? Okay, so we have to keep going down. After a while, you'll discover that the answer is 31. Not that long. Nah, not that long. You can use logs. So for those people who have studied logs, and we will study logs in a couple of weeks, you can actually just hit this in on your calculator. Log 1.025 2.164 by using the log base button here. We will do logs later. Yeah, there is. It's on the top right, I think.
But if you just try log 2.1 for overcross,
Yeah, that way too. This is the quickest way to do it. Yeah. What? Are you feeling okay? Okay, can I scroll down? Yeah. Now, business students, in economics, have you done loans and banking and capital reserve or not? Have you done money and circulation?
No.
What are you doing at the moment? Supply demand? Elasticity. What were you doing before that?
Actually, no, it's still a long way to go for that.
Okay. Oh well, I'll still do it anyways. Okay, so well, this is for everyone, but it has an economics relevance. But it is for everybody. And Donald will do this with you later. He will give you the formula, and you would like to wonder maybe where the formula came from. So, just a basic idea for everybody. Banks, you know, you can put in money and you can take out money. So you can save money with the bank, or you can get a loan. So what people sometimes don't know is the bank lends more money out than it takes in. And you might be wondering, how is that possible that the bank can give out more money than it takes in? And the answer is because banks know that they never have to keep everyone's money available at the same time, because not everybody will want their money at the same time. So for example, if one person puts in 1,000, another person puts in 1,000, and another person puts in 1,000, the bank has 3,000. It doesn't need to keep 3,000, because maybe tomorrow this guy will want to take only 100, maybe tomorrow this guy will want maybe 50, and maybe the next tomorrow this guy wants 200. So if it keeps all 3,000 there, that's it doesn't need to do that. It only needs to keep a little bit. It's only a problem if all three people want all their money at the same time. And that actually has a name. It's called, does anyone know? It is like bankrupt, it's called bank run, where everybody looks for all their money at the same time. Anyways, in most countries, banks only keep 10% and they lend out 90%. So in this example of the 3,000, the bank keeps only 300 and then it lends money to someone else, 2,700. So this is the basic idea. You get that? Yeah, okay. So let's look at what happens in this world. So just to be very, very clear, the only money I have is 100 euros. That's all the money there is. I put this into the bank. How much will the bank keep? 10 euros. So there's a 10 euro note in the bank. And it gives a loan to someone else of 90. So this person here gets 90. Now this person has 90 euros, they got a loan, maybe they want to buy something, so they buy something, that's fine. They give the money to the shop, and where does the shop put the money? So this goes into another bank. And this bank will keep 9 euros and then loan 81 euros. So then another person gets 81. Now think about what's happened so far. I have given 100 to the bank, but 2 people got more money than what I started with. Yeah, because 90 plus 81 is more than 100. So I'm kind of making money here. Yeah. So let's see how much money my 100 euros has made. So I've had 100 euros, but then another person, they got 90, and then another person, they got 81, and this will continue. This is GP. A equals 100, or equals 0.9. So the total is A over 1 minus or, which is 100 over 1 minus 0.9, which is 1,000. So my 100 euros of cash has made 1,000 euros of cash. Do you see what's happened there? Now, this is what happens if there is a problem. If I don't spend my 100 euros, if I don't put it in the bank, because I think the bank is about to fail, then what happens to this? All of this is gone. So it means there's 1,000 euros less in GDP. You've done GDP? Yeah. So GDP has reduced by 1,000 euros because I did not put my 100 euros in the bank. So with Donald, you will do a formula like this, where A is the money that is in deposit on the bank, and or is what's called the reserve, how much the bank has to keep. So when you see this formula with Donald's class, you can know where it came from. It came from this lesson. Yeah. So I think this is quite interesting. It basically means governments don't make money, banks do. So we think about the government printing money and making money. Not really. It's the banks that make the money by lending money out that they don't have. Yeah. So I just thought now for the economics students, you might find this an interesting practical problem for GP. Okay. Now the questions I want you to try for a few minutes. These are important for the exam, and you can see each question is different. So you have to do all of these. I'm sorry to tell you. You need to try all of these. So finish all questions. Okay, you can start them now. So finish the ones you haven't done. All of them.